What if gravity suddenly turned off for 5 seconds? At first, this sounds obvious. Gravity is just there. It's the quiet rule that holds everything down. Your chair, the floor, the air resting gently around you. Even the feeling of your body leaning a little into the seat right now, that's gravity doing its quiet work. We almost never notice it, which is strange if you think about it. Because gravity is actually doing something incredibly active all the time, yet it feels like nothing at all. Like silence in a room that you only notice after someone turns off a fan that's been humming for hours. So let's imagine something very small. Not dramatic. Just 5 seconds. Gravity turns off. Only 5. Now the first reaction most people have is simple. They imagine floating. Like astronauts in space. Your feet lift off the ground, maybe your coffee cup drifts upward, a few loose papers rise slowly like sleepy birds. Maybe you smile a little at the thought. But then something feels off. Because we're not actually in space. We're on Earth. And Earth is moving in ways we usually ignore. Let's slow down for a second. Right now, even while you're sitting still, you're moving with the surface of the planet. The Earth is spinning, quietly, smoothly, and you don't feel it because everything around you is spinning with you. Your chair, your room, the walls, the air. It's all part of the same motion. Gravity is the thing quietly holding you to that moving surface. So if gravity suddenly disappeared, even briefly, something subtle but important changes. You're no longer being held onto the spinning Earth. You still have the motion you already had, that sideways motion from the planet's rotation. But now, there's nothing pulling you toward the ground anymore. And this is where the imagination gets interesting. Picture the room you're in. A quiet room at night. A chair. A table. Maybe a cup sitting somewhere. Now imagine that exact room, but gravity is suddenly gone. Not slowly fading. Just gone. For the first tiny fraction of a second, nothing dramatic happens. Your body doesn't immediately fly upward the way movies show. That's a common picture, but it's not quite right. Instead, something quieter happens. Everything simply stops being pressed downward. That pressure you've always felt, even if you never noticed it, disappears. Your body stops pushing on the chair. The chair stops pushing on the floor. It's almost like the whole room forgets which direction down is. And then things begin to drift. But the drifting is strange. Because the Earth is still spinning beneath you. You and the ground were moving together before gravity turned off. But the moment that connection disappears, your path and the planet's path begin to separate just slightly. Not violently, just enough to feel unsettling. If you were watching in slow motion, you'd see something almost gentle. Your body lifting just a little away from the chair. The chair beginning to slide away from the floor. Tiny dust particles rising into the air like they've been waiting for permission their whole lives. And the air itself, that's something people rarely think about. Air has weight. It presses downward because gravity pulls it toward Earth. Without gravity, the air wouldn't behave the same way. It would start to loosen. Not instantly escaping into space, 5 seconds is too short for that, but the structure of the atmosphere inside the room would begin to soften, like a stack of blankets suddenly released from being compressed. And somewhere in that moment, you might notice something odd. Your sense of balance would disappear. Because your inner ear, the little system inside your head that tells you which way is down, relies on gravity too. Without it, orientation becomes uncertain. Up, down, sideways, those ideas start to blur. This is where it gets uncomfortable. Because we usually think gravity is a force that pulls things downward, like an invisible hand grabbing everything. But when you sit quietly and imagine it disappearing, you start to realize something deeper. Gravity is what makes down exist at all. Without it, direction itself becomes negotiable. Let me try a different angle. Imagine placing a book on a table. Simple scene. You've seen it 1,000 times. The book rests there, unmoving, solid, stable. But that stability isn't actually normal in the universe. It only feels normal because gravity constantly presses the book into the table and the table pushes back. There's a quiet conversation happening there all the time. A continuous push and resistance. Remove gravity and the conversation stops. The book doesn't fall upward. It just stops being held in place. Which means the world we think of as still is actually a carefully balanced situation. Almost like everything is leaning into gravity without realizing it. Now go back to our 5 seconds. We're maybe 1 second in. You're drifting slightly away from the chair now. The chair is drifting too, not because something pushed it, but because nothing is holding it anymore. The earth beneath you is still rotating eastward, quietly sliding under everything that was once attached to it by gravity. And here's something physicists found a bit unsettling when they first started thinking about motion like this. Objects don't really like to change their motion. They prefer to keep doing whatever they were already doing. If something is moving, it keeps moving. If something is still, it stays still unless something interferes. Gravity is one of those constant interferences. It's always nudging motion downward. Without it, things reveal what they were already doing all along. This is the part people don't expect. You wouldn't suddenly shoot straight up into the sky. Instead, the Earth would quietly move away from you. And if you're near the equator, where the planet spins fastest, that sideways separation would be more noticeable. Not dramatic in 5 seconds, but enough that if gravity suddenly returned, you might not land exactly where you started. Which is a strange thought. Your house would have moved slightly beneath you. The planet itself continuing its silent rotation while you were briefly untethered. And if we slow this down even more in our imagination, almost like watching time stretch, the room becomes a kind of floating puzzle. A lamp drifting away from a table. A glass of water turning into a slow-moving sphere of liquid in midair. Curtains lifting gently as if the room forgot which way the floor was. There's something peaceful about it, but also slightly wrong. Because gravity isn't just holding objects down. It's holding our everyday expectations together. Without it, the idea of resting changes meaning. You begin to notice how many things in life depend on that quiet downward pull. Your footsteps, rain falling, the way dust eventually settles. All of it depends on gravity constantly guiding motion. Without it, the world becomes a place where motion doesn't resolve the way we expect. Things don't return to the ground. They simply continue. And this is the point where physicists, including thinkers like Richard Feynman, often paused and asked a question that sounds simple but becomes strangely difficult. What is gravity actually doing? Because when you look at it closely, gravity doesn't behave like pushing or pulling in the everyday sense. It reshapes motion itself. It tells objects which paths feel natural. And when it disappears, even in imagination, those paths reveal themselves. We start to see that the calm, stable world we live in isn't really the default state of the universe. It's a special arrangement, a quiet agreement between motion, space, and this invisible influence we call gravity. Now imagine we're 3 seconds into the 5. Not long, but long enough for the room to look unfamiliar. Your body drifting slightly above where the chair used to support you, the floor no longer something you rely on. And maybe, just maybe, in that moment, your brain would begin to do something curious. It would start trying to redefine what standing means. Because standing only makes sense in a world with gravity. Without it, you're just moving through space with everything else. Even now, actually, that's what you're doing. The difference is that gravity keeps redirecting that motion in a way that feels stable. But once you start seeing it like this, something subtle shifts in your mind. You realize we're not really living on solid ground in the way we imagine. We are living inside a constant interaction between motion and a quiet bending of how things move. And if gravity paused for just 5 seconds, not long enough to destroy anything, not long enough to throw the oceans into chaos, just long enough for the world to loosen its grip, you might notice something you've never noticed before. That down was never guaranteed. It was being continuously created, moment by moment, held together by something we rarely feel directly. And if we let the thought linger there for a moment, just sitting in that quiet floating room, watching dust slowly drift in a direction that no longer has a name, there's another small detail that begins to appear, which at first seems unrelated, but then, the more you look at it, the more it starts to connect. Because something else is happening during those 5 seconds that is even quieter than floating objects. Time feels a little different when motion loses its usual direction. Not in the dramatic science fiction way people imagine, not clocks melting or anything like that, nothing flashy, but your brain, the system that constantly predicts what will happen next, would start to hesitate. Normally, your mind knows what comes next. You drop something, it falls. You let go of a pen, it hits the floor. You jump, you come back down. Gravity makes the future predictable. Remove it, and suddenly the future becomes slightly undecided. And that hesitation inside your mind is interesting, because it reveals how much of our understanding of reality depends on one quiet rule we rarely question. Let's imagine we are 4 seconds in now, still floating gently. If you reached out your hand slowly, you might notice something odd about the motion itself. Your hand would keep moving even after you expected it to slow down. Not wildly, just a little longer than feels normal. That's because, in everyday life, gravity is always subtly influencing motion, directly or indirectly through contact with surfaces. But here, in this short pause of gravity, motion becomes more honest. Things reveal their natural tendency to just continue. And that's something that puzzled physicists for a long time. Because if you step back far enough, you begin to see that gravity is not just something pulling things down, it's shaping the paths things prefer to follow. Without gravity, objects don't suddenly become chaotic. In a strange way, they become simpler. They just move. Quietly. Straightforwardly. Almost like the universe saying, "Fine, if nothing is getting you, just keep going." Now picture the planet below you during these same seconds. The Earth is still rotating, still carrying oceans, mountains, cities, all moving together through space in a smooth, continuous motion. But for a brief moment, the connection between that motion and the objects on the surface loosens. You are no longer pressed into the moving Earth. You're sharing its motion, but not being held to it. And if someone could watch this entire scene from far away, far enough to see the curvature of the planet, they might notice something subtle. Millions of tiny things near the surface lifting just slightly away. Not exploding outward. Not flying off dramatically. Just detaching a little. Like the world took a slow breath. And during that breath, something else becomes easier to notice. Gravity isn't something that occasionally acts. It never stops acting, which means the world we think of as normal is actually the result of constant guidance, constant shaping of motion, almost like the universe is quietly adjusting every step, every fall, every drifting particle of dust. Now we reach the fifth second, the very edge of our thought experiment. And just before gravity returns, just before the floor becomes down again, there's a moment where everything is suspended in a kind of neutrality. Not weightless in the dramatic sense, more like directionless. And in that moment, you might realize something that usually hides behind familiarity. The ground has never been truly solid in the way we imagine. It only feels solid because gravity continuously presses everything into contact. Take that away, even briefly, and the idea of rest dissolves. Objects don't really rest. They're just constantly being guided into certain paths that happen to look like stillness. And then, gravity quietly returns. No sound, no flash, just the sudden reappearance of direction. Down comes back. Your body reconnects with the motion of the earth beneath you. The chair meets the floor again. Dust begins to settle, though maybe not exactly where it used to be. Water droplets drift back toward surfaces. Tiny adjustments everywhere. The world resumes its usual conversation between motion and gravity, as if nothing unusual happened. But if you had experienced those 5 seconds, really experienced them, something would stay with you afterward. A slight awareness that what we call normal is actually a very specific arrangement of invisible influences. That the stability of a room, a chair, a floor beneath your feet is not guaranteed by the universe by default. It's being maintained continuously. And once you begin to see gravity that way, it becomes harder to think of it as just a force pulling things down. It starts to look more like a quiet organizer of motion. A background rule that shapes what feels natural and what feels strange. Which leads to an even softer question that physicists eventually stumbled into, almost accidentally. If gravity is constantly getting motion like this, then maybe objects aren't being pulled the way we first imagined. Maybe what's really happening is that the paths things follow through space are being gently curved all the time. And if that's true, then even right now, sitting in this quiet room, feeling completely still, you might actually be following a path through space that only looks straight because gravity is shaping it in a way your senses have always accepted. And if we pause there for a moment, just before asking what those paths really are, there's a small detail about the way space itself behaves that starts to become important, but it's easier to notice if we think about what would happen not after 5 seconds, but if gravity hesitated just a little longer.